All right, so this video is going to start on page 12. We're going to look at force versus time graphs. So remember, impulse equals force times time. And if you look at your graph, your force is your y-axis and your time is your x-axis. So if we want to find impulse on a graph, what we need to do is we need to find the area beneath the curve. So that's the area between the graph line and your x-axis. What I mean is like this area all through here and this area all through here. Okay, so what we're going to do is we're going to break this up into sections because these are interesting shapes. So we're going to find the area of rectangles and squares. So remember, and triangles, if you want to find the area of a rectangle or square, it is base times height. And if you want to find the area of a triangle, it is 1/2 base times height. So what I'm going to do is I'm going to break this into sections. So right here, what I'm going to do is I'm going to make a little rectangle here. And then that creates this section right here next to it from 1 to 2 seconds. So I'm going to split this in half and do a triangle and a square. And then I'm going to leave this rectangle alone right here. I'm going to draw a line there, and that creates another triangle. And then I'm going to go on the bottom side, and I'm going to draw a line up from 8 to make that a rectangle and a triangle. So what we're going to do is we're going to find the area of each section. So be careful when you're doing this. So my base for the first section is 1. My height is 8. So 1 times 8 is 8. Okay, so when you're doing these graphs, make sure you're paying attention to where you start versus where you ended. So if I'm trying to find the area of this square next, it went from 1 to 2. Okay, so that's a base of 1. And then my height goes from 0 to 4. So 1 times 4 is 4. Then my next triangle is my base is 1 again. My height goes from 4 to 8, so that's 4. 1 times 4 is 4. Half that is 2. Then I'm going to do my rectangle here. So I go from 2 to 4, so that's a base of 2. Height of 4. 2 times 4 is 8. And then I'm going to have another 2 on my triangle right there. Now we're going to do this big triangle here. We're going to go ahead and say it stops at a nice even 5 for the sake of this problem. I don't want to do decimal stuff. So it goes from 5 to 8, so that's a base of 3. And then a height goes from 0 to -10, so that's -10. So 3 times -10 is -30. Half that is -15. Okay, so please don't forget the half part. That's what we're seeing is some students forgetting the half part. And then I'm going to do this last square. I have a base of 2 and a height of -10, so that is -20. So those are all my areas for this graph. Now it says a 2 kilogram object initially at rest, so there's mass, so make sure you pay attention to what we give you. Initially at rest means VI is going to be 0, is acted upon by a force described by the F versus T graph. What is the impulse given to the object in the first 5 seconds? That means what we're going to do is we're going to add up all of our area on the graph up until 5 seconds. So that is where it stops right there. Okay, so I would do 8 plus 2 plus 4 plus 8 plus 2, and that's going to give you 24 newtons times seconds. Now, if I want to know what is the total change of momentum of the object in the first 10 seconds, you've got to remember that impulse and change of momentum are the same thing. Okay, so there's no new way to doing number 2. It's just you're going to add up the area all the way up to 10 seconds now. Okay, so what we're going to do is we're going to take that 24 that we already know up until 5 seconds. We're going to minus 15 and then minus 20. Okay, and that's going to give you -11 newtons times seconds. So the purpose of me saying impulse and then momentum is because momentum equation is technically P equals M times VF minus VI. Okay, so you've got to understand that P is also a value you can find on the graph just by finding the area up until that point. So we're going to find the velocity at 2 seconds. So at 2 seconds, we're going to do is what is our area up until 2 seconds? So what we would do is we would find out what is the area up until this point right here. So 8 plus 2 plus 4 is 14. Okay, so 14 equals your mass. I already told you your mass was 2. And VF, okay, so we don't know VF. We're going to leave it VF. And VI is 0, so you can just leave that off. So it's 14 equals 2 VF. So that gives you a final velocity of 7 meters per second. Now at 6 seconds, what we're going to do is, let me clear up some of this. There we go. So we're going to do it 6 seconds. That means I got to figure out what is this little triangle right here. What is this area of this? Okay, so the base would be from 5 to 6, so that's 1. 1 times -3 is -3. Half that is -1.5. So I would take that. I would find out what is my total area up until 6 seconds. That is going to be 22.5 equals 2 VF. So the good news is once you know that right side, once you know it's always 2 VF, it stays the same the entire time. So 22.5 divided by 2 gives you a final velocity of 11.25 meters per second. Now at 8 seconds, what we're going to do is we're going to go ahead and get rid of this little triangle right here, okay, because we're seeing some instances where people are starting to add that 15 and that 1.5. Okay, at 8 seconds, we're just going to pretend all that stuff went away, and we're just going to draw our line right here, so that's where we're going to stop. So add all that up, and you should get a momentum of 9. 9 equals 2 VF. VF is going to equal 4.5 meters per second. D, we're at 9 seconds, so at 9 seconds, what we're going to do is we're going to have to split this up a little bit, so let me clean up this line. What we're going to do is we're going to split this in half. Okay, because we need 9 seconds, so that's going to be negative 10. So we're going to add up all the points up until 9 seconds. Okay, and that's going to give you a momentum of negative 1. So negative 1 equals 2 VF. So your V final is going to be negative 0.5 meters per second. Okay, so that is how you do number 3. Number 4, what is the object's acceleration at 3 seconds? So we have force, and we're looking for acceleration. So remember, force equals mass times acceleration. So at 3 seconds, all we got to do is go up here to our graph. Where are we at 3 seconds? We're right there. We're going to go all the way, look to the left, and you're going to notice that you're at 4 newtons. Okay, so that is your force. So 4 equals your mass, which is 2, times A. So divide both sides, and you get an acceleration of 2 meters per second squared. Now at 8 seconds, we're going to go back up here. At 8 seconds, we're right here. So we're going to go all the way to the left, and we're going to look there, and that's a negative 10. So negative 10 equals 2A. So A is going to be negative 5 meters per second squared. What is the object's final velocity at 10 seconds? Okay, so when we found velocity up here at number 3, we're going to use the exact same steps here. Okay, now we're just doing the whole thing. Okay, so what is my total momentum after 10 seconds? You're just going to add all that up again. Okay, so we're going to go ahead and get rid of this line. Okay, get rid of this. We're going to go back to what our original thing had. We're just going to add it all up, which we already solved for that number 2. It was negative 11. So negative 11 equals 2 VF. So VF is going to equal to negative 5.5 meters per second. Okay. Now we're going to go on to the next graph. So my next graph is force versus time graph. So I'm going to do is I'm going to go ahead and start breaking it into sections. Okay, so I'm going to do is I'm going to draw a line down here to make that triangle. I'm going to draw a line down here to make that rectangle. And a lot of times I like to just go down from the angles. So I'm going to go down here, and I'm just going to split this into a triangle and a rectangle. And then I'm just going to put one line going down here, and then you have a big rectangle and triangle. Honestly, it doesn't matter. You can do it whatever way you want to. As if you can get the same values, however you want to draw it is up to you. Okay, so then on the next part is at 9 seconds, I'm going to draw a line up here to make a triangle and a rectangle. So there's my areas. So from my first triangle, 0 to 2, so 2 times 10, half that. So 2 times 10 is 20, half that's 10. Okay, my little rectangle right here, 1 times 10 is 10. My rectangle here, my base of 2, 2 times 10 is 20. Okay, my next one is a base, my triangle is a base of 2, 2 times 10 is 20, half that is 10. This next rectangle is going to be base of 2, 2 times 20 is 40. And then I have a base of 1, 1 times 20 is 20, half that is 10. Then I'm going to go here, I'm going to do 1 times negative 20, half that is negative 10. Okay, and then 1 times negative 20 is negative 20. So there are my areas right there, so we'll see what we need to do with them. Okay, make sure you read this part under the graph. It says a 5 kilogram object, so there's your mass, is moving with a initial velocity of 2 meters per second. So now we actually have a VI. Okay, so we can't say VI is 0 anymore, so we're gonna worry about that later. 1, what is the impulse in the object so in the first 8 seconds? That means what we're going to do is we are going to add up the area all the way till here, and that's where we're going to stop. So 10 plus 10 plus 20 plus 10 plus 40 plus 10 is going to give you 100 newtons times seconds. Number 2, what is the total change in momentum? So remember, it's the exact same thing as we did in number 1. We're just going to do it for the whole 10 seconds now. So I'm going to get rid of this red line because now we're going to find out the whole thing. So 100 minus 10 minus 20 is going to give you 70 newtons times seconds. So we're going to figure out what is the object's velocity at 2, 3, 5, and 9 seconds. So remember, P equals m times VF minus VI. Okay, so what is my momentum after 2 seconds? So after 2 seconds, we're going to stop right here. That is just 10. So 10 equals my mass, which is 5, times VF, I don't know, but now I know VI is 2, so minus 2. So there's two ways you can do this. One is you can go ahead and divide both sides by 5 to get rid of that whole parentheses thing. Or if you don't want to do it that way, just remember you can cross multiply into this. Okay, as long as you're getting the same answer, it doesn't matter. You should get a velocity, a final velocity of 4 meters per second. Okay, just watch out. Just don't forget initial velocity and make sure you're doing your algebra right. Okay, so we're going to do, let me clear up some room, is we're going to do 3 seconds now. So at 3 seconds, I would do 10 plus 10 is 20. So 20 equals 5 times VF minus 2. And you get a final velocity of 6 meters per second. Okay, C is 5. Okay, so at 5 seconds, we're going to add it all up till 5 seconds. So 10 plus 10 plus 10 plus 20 is going to give you 50. So 50 equals 5 times VF minus 2. So VF is going to come out to be 12 meters per second. And at 9 seconds, so 9 seconds, we're at it all the way up till 9 seconds. And that gives you 90. So 90 equals 5 times VF minus 2. Okay, so VF is going to come out to be 20 meters per second. So 4, what is the object's acceleration at 3 and 8 seconds? We're going to do F equals ma. So at 3 seconds, what is our force? So at 3 seconds, we are right here. We're going to look to the left. That is a force of 10. Okay, so 10 equals my mass, which is 5 times a. So divide both sides by 5. And you get an acceleration of 2 meters per second squared. Now at 8 seconds, we're going to figure out where are we at 8 seconds. 8 seconds, you're right here. You're on the 0 line, so you have a force of 0. So 0 equals 5a. A therefore equals 0 meters per second squared. Now it says, what is the object's final velocity at 10 seconds? So now we're going to use what is your whole momentum after 10 seconds, which we already solved that number 2. So 70 equals m, which is 5, times VF minus 2. Solve for VF, and you should get 16 meters per second, and that'll end that one.